Hello friends, this video on application of derivatives part 22 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 21. Till now what we have seen is finding the slope we have to find f dash x, and then we have to find f dash x plus h, there is number just left to x, and f dash x minus h, there is number just right to x, and compare. And that's a little tricky, not tricky, a little cumbersome, lot of calculations involved. To make our life simple, we'll go for a second derivative test. Second derivative test will easily tell you whether it's a local maximum or minimum. So if f is a function defined in the interval L, again same thing with c is any number on this interval, and f is twice differentiable. Please note this condition has to be true, then only we can apply this, because if it is not twice differentiable, will not be able to use second differentiable test. So the test says that if again c is a point and f dash xc is equal to 0, that means c is a critical point. C can be local maxima, c can be local minima, or c can be point of inflection also, correct? But we don't know. To find that, if we find f double dash c, and if this is less than 0, my c is local maxima. Please note, it is less than 0, so it is maximum. It's other way around actually. Same case, if my f dash c is 0, I don't know it is local maximum or minimum or point of inflection. What I do is I find f double dash c. If my f double dash c is greater than 0, then it is a local minimum. This test fails if f double dash c is 0. In this case, again we have to go back to the first derivative long test, and then we have to find whether it is a local maximum or minimum. Correct? There we have to find f dash of c plus h, f dash of c minus h, where h is very less number, and then you have to see whether the slope is changing, which direction is changing, and then we can find this local maximum or minimum. But that's a cumbersome task, so we found this second derivative test. You just double differentiate. If it is less than 0, please note, less than 0 means maximum, greater than 0 minimum, equal to 0, that means the test is failing. We have to go to the first derivative test. Let's see how this is. Actually, I'll tell you graphically how, when you say f double dash c is less than 0, it is maxima, and f double dash c is greater than 0, it's minima. Let's see how it is. Let's take this graph, and let's assume my function is something like this, right? But this is the maxima. So this is my fx graph. For this fx graph, since I have to find f double dash x, let me draw f dash x graph also. So the same graph. Now if you see at this point, my slope f dash x is 0, right? So this point f dash x will be 0. These points f dash x is negative. So these points my f dash x will be something like this, negatives, all negative values. The point before this, let's suppose this is the point C actually, right? So point before C, my f dash x is positive. So all these guys will have some positive value. So it will graph like this actually. It will be something like this. This is the graph of f dash x actually. If you plot the values, you will get the graph of f dash. If fx is equal to this, f dash x will be something like this. Now, what is the slope of this? Slope of this is nothing but f double dash x. If you see slope of this is negative slope, correct? Because this makes the angle is more than 90 and less than 180, correct? So what you can see is, if with fx I got f dash x, and f dash x slope is nothing but negative. Why? Because for this graph, see, for this graph the slope is negative, that is f double dash x is negative. Similarly, in this fashion, if I have a minima point like this, my graph is like this fx, and c is the point of minima. For the same graph, if I draw f dash x at point c, the slope is 0. If you go in this direction, if you take any values on this direction, the slope is positive, so my slope will be something like this, positive. If I take values in this direction on the left, the slope is negative, correct? Slope is negative, so this guy's slope is negative. So my f dash x will be something like this. Since my f dash So if my f dash x is like this, my f double dash x is nothing but slope of this graph f dash x, and if you see the slope of this is positive. So I can say that if my f double dash x is positive, it is minima, and if it is negative, it is maximum. That is how graphically you can prove this. See, just understand the concepts. Don't learn all this, because if you understand the concepts, you'll never forget it. Same thing here. If you have this graph like this, it's a maxima kind of graph. For this graph, I have to find f double dash x. So better find f dash x first. I plotted the f dash x kind of graph. Now if I see f double dash x is nothing but slope of this graph f dash x, and if you see it is negative, that means if f double dash x is negative, I am talking about the point of maximum. Similar for minima, if my fx graph is like this, I have to find f double dash x. Before find f double dash x, the first thing is I have to find f dash x. I drew the graph of f dash x, and then f double dash x is nothing but slope of this graph, and that is positive. Let's take one example on this. We have to find the local maxima and minima of, if any, for these two functions using my second derivative test. So second derivative test is, it says that you have to find f double dash x, correct? Since these are continuous function and there is an open interval actually, so I am concerned only about differentiable part fx, f dash x part. Non-differentiable part is not in this picture because it doesn't exist. So let me find for this first f dash x, and that is nothing but 2x. And let me find f double dash x, and that is nothing but 2. If you see, this guy is positive for any number, that is, it is greater than 0. So what I'll get is minima. Okay, so if this f dash x is 0, I get x as 0, and f double dash x, that is f double dash 0, is nothing but 2, that is greater than 0. So it is minima, sorry, that is minima. So 0 is a point of minimum. See, what I've done here is, my fx is equal to x square, f dash x is equal to 2x, my f dash x has to be equal to 0 for critical points, that is 2x has to be equal to 0, or x is equal to 0 is my critical point. Now I have to find whether x is equal to 0 is maxima or minima or point of inflection, right? 3 possible cases. To find whether at x is equal to 0 it is maxima, minima, or inflection, I have to find f double dash x, or f double dash 0 actually, and f double dash 0 is nothing but 2, because f double dash x is 2, it is independent of 0, and this guy is greater than 0. Since it is greater than 0, I can say that it is minima. Correct? So one part is done. Similarly, next part, my gx is equal to x cube minus 3x. I have to find the points, critical points. Let me find g dash x, that becomes 3x square minus 3, and I'll make it as 0 because I have to find critical points. So this means I get 3 into x square x plus 1 into x minus 1 is equal to 0, or x is equal to 1 and minus 1 are my critical points. Now I have to find whether at these points the function is maxima or minima. So I'll take 1 first, right? X is equal to 1. X is equal to 1 you take. Let me find g dash double dash x first. G double dash is nothing but 3 into x square becomes 2x, 3 becomes 0, that is 6x. So g double dash of 1 will be 6 into 1, that is 6, and that is greater than 0. Since it is greater than 0, it is a point of minima. Similarly, when x is equal to minus 1, g double dash minus 1 will be nothing but 6 into minus 1, because 6x, and that is nothing but minus 6, that is less than 0. Since it is less than 0, x is equal to minus 1 is the point of maximum. Correct? So is this question solved now? No. Why? Because the question says find the local maxima and minima. They are not the question is not asking me to find the point of local maximum and minimum. The question is asking me to find the local maximum and minimum. So let's for this do this. My point of local maxima is minima is 0 here actually. So my local minima will be f of 0, that is 0 square, that is 0. So my local minima is 0. In this case, my point of local minima is 1. I'll say point of minima is 1. So minimum value is how much? G of 1. That is nothing but 1q minus 3 into 1, and that is minus 2. Similarly, point of maxima is equal to minus 1, correct? So my maximum value will be nothing but g of minus 1, and that is nothing but xq minus 3x, that is minus 1q minus 3 into minus 1, and that is nothing but minus 1 plus 3, and that is nothing but 2. So if you see, point of minima is minus 2 and point of maxima is 2, and that is my value, correct? So what we have done in this case, first we found the critical points, if you see here, where it can be maxima or minima, but now we are not sure whether this guy is a maxima or minima. So we found g double dash x, and we found this guy is maxima and this guy is minima, on whether g double dash x is greater than 0 or less than 0. If it is greater than 0, it is minima, less than 0 maxima. And then since the question asked me to find local maxima and minima, I found the local maxima and local minima. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.